Okay, welcome to Vector 6, the last chapter of the Vector series. This chapter is important because it actually sums up all the concepts you learn and then apply them to find three things basically. And this slide shows everything here. First thing that we want to find. We make use of everything you learn, your dot product, cross product, whatever, to find angles. Angles between what? Angles between two lines. Alright, you have two lines in space, and then you have angle between two lines. And angle between line and plane. You have a line, you have a plane. Oh, poor drawing, sorry. This is really horrible. So you have a line, and then like that, and you want to have an angle between a line and a plane. Alright. And lastly, if you have two planes, and you'll find the two angle between one plane and another plane. Okay, I'm going to make use of some ideas. I'm not going to go through here, but a quick overview. And do refer to this start of this video because sometimes you got confused what are we learning this chapter. This chapter is all about this. Alright, first, angles. Second, points. Okay, foot of perpendicular. Foot of perpendicular from what? From a point to a line, you draw a perpendicular down, and then this is called the foot of the perpendicular. Correct? And a point to a plane. This is what we call another foot of the perpendicular. And lastly, we talk about distance. Alright, distance from what? Distance from a point to a line. So you realize that point number 2 and 3 are related because once you find the foot, you can find the distance. This is the distance that we're talking about. This is the distance we're talking about. So that gives an overview. Yes, so we'll dive straight into it. And it's a pretty long chapter. Bear with us. Okay. Let's dive straight to the notes now. The first point has been covered. It's just that there's one word missing from a foot of a perpendicular, from a point to a line, or from a point to a plane. I'm so sorry about this. Okay. So, first, angles. Okay, this first part is about finding angles. I think no surprises. Angles are almost always using this definition of scalar product, right? This is the definition of scalar product, or sometimes we call dot product. Correct? A dot B is mod A, mod B, cosine theta. So you make cosine theta the subject here, you will realize that you can find what is theta. So for each question, we need to decide which A and which B do we choose. Alright? And does that give us the angle we want? So broadly speaking, it's like that. I think I will dive straight into the question because that would actually illustrate my point. Let's say you have equations of two lines, L1 and L2. Alright? L1 and L2 here. L1 and L2. Alright? And theta is the angle between you and theta is the angle. You want to find the angle between the two lines. So I think it's not difficult to realize that actually we are more interested in the direction vector. U is the direction vector of L1. V is the direction vector of L2. So as long as I can find the direction vector, I mean the angle between the two direction vector, good enough. Yes, so I suppose maybe I have U here, I have V here. If I can find the angle between the two direction vector, I can find the angle between L1 and L2. Actually, A and B are pretty irrelevant. In this context, in this idea of finding angles, A and B are redundant. It needn't matter what is A, what is B. So, I think it's not difficult. We make use of the definition of dot product, cosine theta, therefore cosine theta is U dot V divided by mod U mod V, and then you get this idea. But you realize that now, if I have angle between L1 and L2, it can either be, you see, if I find U and V here and I happen to find this angle, maybe this is theta. Then the acute angle is just theta. If angle theta is acute, then the acute angle is just theta. But whenever I get two equations of two lines, I may or may not get this U and V nicely such that my theta is acute. let me use an example. This one, okay, I first, I will explain later. Okay, I'll use an illustration later. Let's use numbers. Just use numbers here. I have L1 and L2. Okay, I don't care what is this position vector, it doesn't really matter. I don't care what is this. I know this is the direction vector. So now, if I have L1, direction vector 1, 0, 1, this is the direction vector of L1. For L1. Okay, maybe I should be more precise. I would just say this is the direction vector of L1. And then 1, 0, 1 is here. Direction vector of L2. So what do? I take dot product. I focus our attention here to this either 1, 0, 1, 1, 0 and 1, 0, 1. Divide by root 2, I get half. Nice, very good. I happen to get, I get angle cosine alpha is half, therefore alpha is 60. Excellent, this is 60 degrees. If the question asks for angle, acute angle, between L1 and L2, end of story, I get 60 degrees, I'm very happy. Now, if you learn your equation of line well enough, this is L2, right? This is L2. L2 could have been given like that. And there would have been nothing wrong at all, and it would be the same L2. I repeat one more time. If it's given like that, it would have been the same L2. Just because I multiplied by a -1 throughout, this is still the same line. It doesn't matter. So now I write this -1, 0, -1 here. If you look here very closely, I would -1, 0, 1. Because 1, 0, 1 is in this direction, then -1, 0, 1 is in the opposite direction. So now if I take 1, 0, 1, 1, 0 dot -1, 0, -1, I realize that I get cosine beta, another angle, equals to -half. Then I get angle beta is 120. So okay, I get 120. But very often the question will always ask for acute angle between two lines. So what you need to do once you get 120, you need to take 180 minus 120 to get the acute angle between the two lines. So idea is this. Here, if I have two lines like that, okay, if I have two lines with direction vector u and v, I take u dot v, blah, 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 I get cosine theta. Now, and I end up cosine theta, and end up with theta. Theta may be acute. If it's theta acute, lucky, good. Angle is just theta. If it's obtuse, then you have to take 180 minus theta to get the acute angle. And I must say that question will usually, it's actually almost 100%, ask for acute angle between two lines. So you always have to follow this idea. Can? All good? Yeah. Next. Let's look at example 1. So now another example, I have two lines with these two direction vector. Yes? Like I said, when you want to find acute angle, the position vector, this one needn't matter, this is not important. So all I need to take is the direction vectors, yes, and I take dot -1, 0, -1, dot 1, 1, 2, divided by root 2, 1 plus 1 plus 2, root 6. Yes? Then you get a -3 over root 12. And then you simplify, you get minus root 3 over 2, which is you realize there's a special angle. Oh, because it's negative, all right, because it's negative, then theta is 150 degrees. So, what does it tell us? It tells us that it so happened that when I draw the L1 and L2, the two lines, it so happened that this line, the direction vector chosen is like this, such that I so happen that I obtain this obtuse angle, which is 150. Does it mean that, but now the question asks for acute, all you need to do is to take 180 minus 150, you get 30 degrees. Okay, all good? All right. Next, show that the two lines, part B, different question, these two lines are perpendicular. Always think the moment they ask for perpendicular, you must always trigger your dot product, right? If two vectors are perpendicular, then the two vectors dot will give you 0. So I should not say so much. You just need to take dot product. All right, dot product of the two direction vectors, you happen to get 0. Just take note that this line is important because it's a show question. So this line needs to be written. You cannot just say, oh, happily you just give it 0. Show that you actually have done some working. Can? And then you conclude that they are 0 is 0, then it's perpendicular. All right? All right, question 2. All right, example 2. So, an equation of a straight line is this. All right? And a point A on L is given by t equals to 0. I think it's a good idea to practice doing a simple sketch. This is L. Yes. And a point A is here. A is on L such that t is equals to 0. So when t is 0, it is 1, 2, 3. I deliberately write this as coordinates now. Yes, coordinates. A is a point with coordinate 1, 2, 3. So L is like that. And you have a direction vector minus 1, 1, 1. All right? Calculate the acute angle between OA and L. So O is somewhere here. I don't know where exactly it's O, but O is somewhere out there. So let's see. You want to find the angle between OA and L. Let's look. Which two vectors should I consider? When you want to find acute angle, you just have to identify two angles. Problem solved. Dot product, problem solved. So which two vectors? I think it's quite clear. It is this vector OA and this direction vector of the line. Right? Yes? So to find OA and L, consider, therefore we consider cosine theta, we call it theta. I will take this one and this one. Minus 1, 1, 1, dot 1, 2, 3, divided by root 3, root 14. Now after this point, it's just let GC do the work. Not difficult. Evaluate out, you get a 4 over root 3, root 14. GC gives you theta is 51.9 degrees. So in this case, you happen to say, oh, okay, acute angle, no need to do anything. They ask for acute angle. It so happen that it's acute angle, done. It is 51.3. Sorry, 51.9. All good? Yes. Next problem. Next part. There's a point B on L given when t goes to -4. So let's refer to this diagram again. This is point B. I don't know where it's B. B is somewhere here. Okay. Such that t is -4. You sub -4 in here. You calculate, you get this one. You get 5, -2, -1. So let's jump straight. Let's use this diagram instead. 5, -2, -1. So you have this one. 5, -2, -1. And OA is 1, 2, 3. So now the question asks for the angle here, AOB. Do you find this question familiar? Finding an angle, AOB. This is a CT1 question. All right, CT1 question. So I think most of us are able to tell me, oh, okay, I take OA dot OB, OA and OB. I thought I will get, the definition tells me that OA dot OB mod OA mod OB cosine theta. So cosine AOB. Done. So I think this is not difficult. So in order to find this angle, I need to consider two vectors. They are both outward facing from this point, or both inward facing. So which means I can easily try and be difficult and do this. Correct? I can easily write that as well. No problem. If you want to do that, sure, no problem. But I don't know why you want to do that. But okay, then we put in the numbers. The numbers is not difficult. It is the idea. 1, 2, 3 dot 5 minus 2 minus 1. Now, can I please urge all of us, practice doing this dot product, cross product carefully. I repeat, carefully. A bit of calculation error will really affect your answers in the subsequent parts. Yeah? So, I mean, if it's the last part, it won't affect that much. I mean, if it's the first part, then you will have a lot of problems later on. The numbers are not nice, blah, blah, blah. Then you got a lot of problems. So I urge all of us to be very careful. Okay? You get a negative number, which suggests that eventually I will get AOB. I inverse cosine, I get 95.6. Okay, I look up here. My question is this. I got 95.6, right? Mr. Wu said obtuse angle, I must take 180 minus 95.6. Do I need to do that in this case? The answer is, don't look at your notes, the answer is no. You don't? Why? Because for 3 points in space A, O, B, this could well be 95.6. And it is 95.6. Nothing can change the fact that it's 95.6. You will only take 180 minus the obtuse angle for angle between two lines. This one is a specific angle in space. For example 1, maybe we want to refer to example 1 now. I look at this. In example 1, it was angle between two lines. Correct? Then, okay, you could have, the question asked for the acute angle. But you also happen to find the obtuse angle. Of course, you take 180 minus that. But in this case, I have 3 points in space A, O, B, and I take outward pointing OA dot OB. Then I get 94.6, just leave it as 95.6. Don't try and be funny. Alright? Next, the questions say, not a question, there's a point there that you cannot take AO dot OB. Why? Because not both are outward facing or inward facing. Correct? And this is the point that I was trying to make. Cannot. Please don't. Alright? Please don't. Cannot take this one. You know why? You know why. And I hope that you don't make the mistake. So please contrast example 2 with example 1. Because example 1, you will take 90 minus this, 180 minus this. Whereas example 2, you leave it, especially 2 part 2, you leave it as it is. Please. Okay? All good? All right.